This video is going to talk about the short-run cost curves of the firm. This is another video for Chapter 8 out of the textbook. In the short run, as the last video discussed, we can distinguish between fixed and variable costs. So we have some factors of production are fixed in the short run, and so that's going to give us the fixed costs that a firm has. And then the factors of production that can be varied are the variable costs. So when we go to graph this, we're going to have four different cost curves, and this would be what we call our set of short-run cost curves. Three of them are the average cost curve. So we have the average total cost. Remember, as explained in the prior video in the short run versus long run, total cost can be divided between fixed costs and variable costs. And so if we can sum up the cost that way, we can divide by Q. And so the average total cost would be the average fixed cost plus the average variable cost. And then we have marginal cost. We're going to have marginal cost on there. In particular, average total cost and marginal cost will be very important when we try to explain the behavior of a firm. So if we have the four cost curves drawn up here, again with the short abbreviation labels. This is average fixed cost, average variable cost, average total cost curve, and then the marginal cost curve. Now, we've drawn them with a certain shape, and we can explain why it is that certain of these curves have to have a certain shape. Well, average fixed cost is actually pretty easy to get to because because their fixed inputs are fixed. Whatever their quantity, whatever the quantity, whatever the type they happen to be, the fixed cost is going to be a fixed number. And then you're simply getting average fixed cost by taking that fixed number and dividing it by a bigger quantity. So if the fixed cost was, say, $120, then the average fixed cost is just 120 divided by Q, and all you have to do is, as you divide by a larger and larger quantity, the fixed cost per unit, your average fixed cost, has to be getting smaller. You're taking that fixed quantity, a fixed dollar amount of cost, and then dividing by a larger and larger quantity. So the average fixed cost curve is going to look like this. It's going to be declining. It's not going to get to be zero, but it will get, when you get out to a really large Q, the fixed, if it's even possible to produce that much output, given the fixed amount of your quantity, the average fixed cost will be approaching the horizontal axis. They'll be smaller and smaller. The average variable cost would draw as, it could be declining for a while. You typically will draw it, if you think of it, it's got like a J shape to it. We think the average variable cost, the variable costs are the things like labor and raw materials. And one of the things is, we figure that, like many times as you start to hire labor, you can actually operate a factory very efficiently. If you don't have enough people in a factory, maybe you can't even run the assembly line the way it's supposed to work. So if you think about it, when you have enough people, you can actually run the assembly line as it's worked. You'll be increasing output enough that the average variable cost, the variable cost per unit of output, might actually be falling for a while. And that it would be falling because the output is rising so fast is rising faster relative to the amount of variable input that you have to hire. But then it's going to start to go up, and that's because at some point in time, there's only so much you can do by hiring more variable input. You end up you think about it, if you're running a farm and you've got 100 acres, there is going to be a limit to the amount of soybeans or corn or peanuts that you can grow on 100 acres. Even if you use other variable inputs, you use lots of labor, lots of fertilizer, lots of water, everything else you might want to possibly do. At some point, you get the case that it's going to be hard to try to squeeze out extra output. You'll have to be using a lot of extra variable inputs, and that means it'll be very costly to get that extra output produced. And well, that actually was also a very good story I just told to explain the shape of the marginal cost curve. The marginal cost curve, we're going to assume that marginal costs are going to be rising, getting very high, simply for again, the reason I was just telling. With some factors of production fixed, you can try to hire the others and try to substitute for them, but at some point you run up to that limit. Like there's only so many acres you have to grow crops on, or your factory's only so big, or you only have so many drill presses or saws. Like suppose you're trying to cut down trees and you only have so many saws and so many trucks. Then there's a limit to the number of trees you can cut down. And even if you get a whole bunch of workers and a whole bunch of other things to help you, that cost of trying to cut down extra trees, it becomes very high because you've simply run out of your fixed, in one sense, you've run out of fixed input. And so that's why we think about this marginal cost gets very high. You might even want to think about if it becomes impossible to squeeze out any extra output, then you might even want to think about, oh, that marginal cost becomes infinite. So the marginal cost gets very high. And so we have that there as the shape of it. And then that's going to draw up the average variable cost as well. And then the other thing is that the average total cost is going to be sort of U-shaped here. And we can see it's going to be the sum of the average fixed cost and the average variable cost. So for a small quantity, the average total cost is going to be mainly fixed cost. It's going to be driven by the fixed cost because, again, you've got a fixed amount of that fixed cost. And for a small number of units, that turns out to be a very, very high cost per unit. So the high part of the ATC over here is driven by the high fixed cost, and then the high part of the ATC over here is driven by the variable cost. As the variable cost becomes high. Another way of thinking about this is because the average fixed cost is getting smaller and smaller, and the ATC is the AFC plus the AVC, then as the quantity gets larger, the average total cost gets closer and closer to the average variable cost curve. And as the average fixed cost becomes almost zero, then the average total cost would be almost entirely variable cost. These two curves get very close together because this one's getting close to zero. There's one other thing that we can tell in here, and we have it drawn here. And if you had to draw these graphs on an exam, it would be an important thing for you to remember. And that is I said that the average variable cost curve has sort of like a J shape to it, and the average total cost curve has a U shape to it. And the marginal cost curve is actually intersecting the AVC and the ATC at the bottom of those things. So at the bottom of the J here, and then at the bottom of the U in the average total cost curve. This reflects a mathematical relationship between marginal and average. Marginal is your next cost, and then the average is your cost per unit. So as an example of this, suppose that you're taking a psychology class. You've had 4 tests so far in that exam, in that class. And your test average to date is 82. Now you take your 5th exam. If your score on the 5th exam is like your marginal score, you may not have thought about those terms, but it would be the marginal score. And then your test average would be your average score. And so if you want to think about that, okay, if your average on if your psych exam average is 82 and you get a 95 on the next exam, what's going to happen to your test average? Is it going to go up or down? Well, even without getting out a calculator and calculating what the new average is, because your score on the next exam is better than your average to date, you can know that your average is going up. If you get a 65 on your next exam, then your average is going down. That's a mathematical relation between marginal and average, and it applies to regardless of what type of variable. So whether you're talking about scores or whether you're talking about costs and producing output. If the cost of producing the next unit is greater than the average or to date, then that average has to be rising. If the cost of producing the next unit is less than the average, then the average would be falling. That was the relationship that we said with the test. And so that means that if the average variable cost curve is falling here, the marginal cost curve must be below the average variable cost while the average variable cost is falling. And then it's got to be above the average variable cost after that. So when it's downward sloping here in the downward part of the J, MC has to be below AVC, and then it starts going up, and that means that MC must be above AVC. That means it had to have intersected it here, and it would be below it here and over it here. And that intersection point has to be at the exact bottom. The same thing here for the average total cost and the marginal cost. Marginal cost has to intersect the average total cost at exactly the bottom of that U. And that's the point at which the cost per unit starts to go up, when the marginal cost becomes higher than the average cost. If you had to draw these graphs on an exam, then that would be one thing. Grading it would be looking to see if you had to do it. In this class, since there are all multiple choice tests, questions for in the exams, if you see a graph on an exam, you'll have the graph there. It'll have this a line there, but there'll be, it is it's drawn this way. It's not drawn by accident. There's a good reason for it, and it's this mathematical relationship between average and marginal. One last thing to note: if you anytime, whether we had labeled this short run or not, if you see the curve, if you see cost curves here, and you have variable and fixed costs, if you have the average variable and average fixed cost, or even if you have just the average variable cost in there, you know immediately that's got to be short run cost curves for the firm, because in the long run, all costs are variable. So if you want to think in the long run, you'd have an average variable cost, but there's no average fixed cost. Since there's no average fixed cost, this curve couldn't exist. And since average total cost is AFC plus AVC, if there's no average fixed cost, then the variable cost would coincide with the average total cost. There's no point labeling that twice. In the long run, all costs are variable. So if you see an average variable cost curve on a set of cost curve on a cost curve diagram, whether the label for that diagram says it or not, that's got to be the short run, because the average variable cost can only differ from the average total cost because there's some fixed costs, and there can only be fixed costs in the short run. So if you see AVC and AFC, whether it's labeled or not, that's the short run. Those are short run cost curves for the firm, because in the long run, all costs are variable.